Significant numbers of personnel we work with use running as their primary source of training. Generally, this is steady state running and often completed on a treadmill. With that in mind, the vast majority are simply not used to accelerating. Now, the need to be able to accelerate effectively is important, not just because of foundational athletic skill, but the tactical relevance aside, also because our personnel must complete a fitness test either annually or biannually based around the MSFT. Whilst this test is aimed at measuring an individual's aerobic capacity, clearly it is also testing the ability to accelerate, decelerate and change direction. Consequently, if we can teach the skill of accelerating effectively, it's possible to substantially enhance an individual's fitness test score without them actually needing to improve aerobic capacity. The technical model for this drill is aiming to achieve optimal body position for that of the drive phase, i.e. a straight line from head through to planted foot. It's common to see people flex at the trunk into a more seated position when they first do this drill, as they are focusing too much on trying to create an artificial lean. As John mentioned in his lecture on sprinting, the lean is a product of strength, not a cued position, and as such it shouldn't be the focus of this drill. Instead, I would ideally like to use this drill to enhance stride frequency during acceleration, so the focus is on achieving the highest cadence possible. I think this is where using a resistance band is more useful than towing a sled or a chute, as the athlete is generally able to focus more on achieving the fast foot contacts than simply hauling the load. This is a concept that was supported by the work of Behrens and Simonson in 2011, who found resisted sprinting did enhance stride frequency. However, they found that if the resistance applied was too much, then sprinting mechanics were altered negatively, a finding that was supported by earlier work by Alcaraz and colleagues in 2005, although it should be noted that they were using sleds. Now this creates another factor for consideration when using band-resisted sprints. When using a sled, you can be confident that the load of the sled will stay constant. However, when using another individual to apply resistance via the band, it does require a fair amount of familiarisation before the partner is able to apply just the right amount of tension to create optimal conditions for the drill. Unfortunately, due to the current setup of our lessons, I've been unable to implement this drill as much as I have done in the past, hence the lack of personally recorded footage. However, when prescribing this drill, I found it is extremely important to explain the purpose beforehand. Otherwise, it can start being used as a conditioning tool rather than for the desired use of enhancing cadence during the drive phase. With that in mind, generally I would limit this drill's use to somewhere between 60 and 90 total metres, split into around 15 metre blocks, ensuring that the individuals take sufficient rest or recovery in order to be able to execute the drill correctly. As a final tip, if you find a bright yellow t-shirt and perform this drill in the middle of a town centre, it's going to massively improve the drill's effectiveness.